Adult stem cells are unique and unspecialized self-renewing cells with the potential to develop into other types of cells. The bones, or bone marrow, are the primary location in which adult stem cells are produced. In day-to-day life, a small number of stem cells are able to leave the bone marrow and travel throughout the body in the circulating or peripheral blood, where they assist in the normal repair and defense of the body. During normal stem cell function, two types of cells in the bone marrow, called stromal cells and osteoblasts, produce a chemotactic protein called SDF1 that attracts stem cells. Also, endothelial cells lining bone marrow blood vessels capture blood circulating SDF1 and release it into the bone marrow. As SDF1 is released or secreted in the bone marrow, chemotactic gradient is formed, with higher concentrations of SDF1 located closer to the stromal and osteoblast cells. SDF1 interacts with the chemokine receptor called CXCR4, which is located on the surface of stem cells, bone marrow endothelial cells, and other stromal cells. As SDF1 interacts with CXCR4, it creates a bond which signals the stem cells inside the bone marrow to crawl toward the stromal and osteoblast cells. The chemotactic signal prevents stem cells from leaving the bone marrow for the peripheral blood. In order to collect adult stem cells, the cells must first be prompted to enter the peripheral blood. Through the administration of a stem cell mobilizing agent called granulocyte colony stimulating factor, or GCSF, enzymes including neutrophil elastase, cathepsin G, and MMP9 are activated inside the bone marrow. These enzymes cleave the SDF1 protein, inhibiting its ability to interact. In addition, the CD26 protein that is expressed on the surface of a subpopulation of stem cells also cleaves SDF1. When interaction between SDF1 and CXCR4 is blocked, the stem cells are no longer held in place inside the bone marrow. They are now free to move into the peripheral blood. Once circulating in the peripheral blood, stem cells can be harvested by a process called apheresis.
Have you been told there is no effective treatment for your diabetes? Do doctors have you on a strict regimen to simply not get worse? Have you tried every drug in the market but still no significant improvement? We want you to know that the technology exists that is proven not only to manage your diabetes, but to possibly reverse the effects. We've treated over 150 patients and conducted successful clinical trials with almost 100% of the patients improving their overall health and vitality. It's not just our patients experiencing success, but you've probably seen talk about stem cell procedures and their promising results on major media outlets such as the New York Times, ABC, NBC, and many others. The question is, why go anywhere else? We're responsible for training hundreds of doctors to perform these procedures, and we'll be sure to put you in the hands of the top doctors in the world, along with the most up-to-date training of any other practice.
In health news tonight, a controversial experimental treatment for type 1 diabetes that seems to have cured a handful of patients outside the U.S. At least that's what they're reporting. But doctors here at home are looking at these developments with great caution. Our report from our chief science correspondent, Robert Bazell.
It is highly experimental and potentially very dangerous, but it could make a big impact on type 1 or juvenile diabetes.
How's the sample looking?
Dr. Richard Burt of Northwestern Feinberg Medical School chooses his words carefully.
I do not use the word cure.
But so far, 14 of 15 patients treated seem to be cured because they have not needed insulin shots for as long as 3 years.
It's an exciting result.
About 1 million Americans, including 7-year-old Sophie Elder, suffer type 1 diabetes. It is an autoimmune disease where the body's disease-fighting system goes haywire, destroying the cells that make insulin. In the treatment, the researchers actually knock out the patient's own immune system, putting them at high risk for infection. Then they coax the immune system to rebuild itself with adult stem cells from the patient's own blood.
A three-toed sloth.
Sophie wasn't in the experiment. No Americans were. The subjects were all diabetics in Brazil. Why Brazil?
There really was no interest or support in America.
Many experts say a big reason is that hospitals in this country would be very reluctant to give permission for such a potentially life-threatening experiment.
I worry a great deal that we are going to see people exporting dangerous types of research to nations where the regulatory review or the understanding of the subjects might not be the same as we get in the developed world.
Sophie Elder's mom, Suzanne, is very cautious about the research.
And I want you to
But she says there is no question Sophie would love to be free of her insulin shots and strict diet.
All I think Sophie really wants is just to be a regular kid.
And despite the controversies, if this early research continues to work well, it could someday help make that happen. Robert Bazell, NBC News, New York.
Have you been told there is no effective treatment for your disease? The procedure consists of an endovascular surgery to repair blocked and narrowed veins leading from the central nervous system as a result of CCSVI. Performed in CCSVI clinical trials, this endovascular surgery has been a successful MS treatment for many sufferers of the multiple sclerosis disease. MS sufferers have seen a marked improvement in their conditions, experiencing better mobility and slowed progression of the multiple sclerosis disease. Our doctors have successfully performed the CCSVI procedure on hundreds of MS patients. To find out more about our multiple sclerosis treatment program, please contact us today. Adipose-derived stem cell treatments also offer an alternative supplemental therapy in combination with CCSVI. Adipose-derived stem cell treatments promote healing of damaged tissue and provide support for diseased nerve cells. The proteins secreted by the stem cells have the ability to protect nerve cells. Those with neurological injury or diseases such as multiple sclerosis and Parkinson's disease may experience many benefits from these types of treatments. The majority of these stem cell treatments for neurological conditions are provided through a catheterization process and implanted directly into the brain. Numerous patients report having fewer aches and pains, less rigidity of joints, more energy, strength, and flexibility. It's not just our patients experiencing success, but you've probably seen talk about stem cell procedures and their promising results on major media outlets such as the New York Times, ABC, NBC, and many others.
Every year, over 10 million people worldwide have an acute heart attack. In spite of improvements in preventative medicine, the prognosis for an ST-elevated MI hasn't changed over the past decade. According to the American Heart Association, after the age of 45, you have a 1 in 5 chance of dying within a year after the initial survival of a heart attack. Advances in regenerative medicine hold the promise to repair damaged tissue and preserve muscle function. The initial effect of a heart attack is that part of the heart muscle dies and is replaced by a scar. The surrounding heart cells, the peri-infarct zone, now need to work harder to compensate. Heart cells continue to die, and the size of the damaged heart area grows, leading to repeat heart attacks, arrhythmias, congestive heart failure, and even premature death. While each of us has cells in our bone marrow that can react to the oxygen-starved tissue, they don't. Amercyte, a Neostem subsidiary, is developing a therapy called AMR-001 that is testing whether stem cells collected from the bone marrow of a patient who has suffered a heart attack can be given after the heart attack to preserve heart muscle that would otherwise die. The The results of Amersight's Phase 1 trial, and other similar trials so far, indicates that our approach can be widely applied if further trials continue to show safety and effectiveness in preserving heart muscle function, leading to fewer adverse cardiac events. This example shows a nuclear scan of a Phase 1 patient's heart after his heart attack. The dark area is dead muscle. Here is the same heart, 6 months post-treatment. Less dark, more functioning muscle. The stem cells are collected from the patient's bone marrow and enriched, not expanded, to increase potency. These cells are stabilized and have a 72-hour shelf life. The cells are infused via the infarct-related artery 5 to 11 days following a stent placement, the optimal time frame to prevent adverse ventricular remodeling. There, they are being tested to save damaged tissue that would otherwise die within days or weeks by releasing chemicals and proteins that grow blood vessels that saves this vital heart tissue, a process called angiogenesis. NeoStem began Amersight's Phase 2 clinical trial in 2012. We completed enrollment of the trial in December 2013 and anticipate data readout in the third quarter of 2014. The company is looking forward to advancing its technology beyond acute heart attacks to other ischemic diseases where AMR 001 could be significant.
This program is a presentation of UCTV for educational and non-commercial use only.
Why is it that I have a small bruise on my spinal cord and I should live my life confined to a wheelchair? Everyone gets bruises. It didn't make sense to me intuitively that paralysis should be forever. One day we will be successful in turning stem cells into cures. We'll be able to be successful in getting out of this wheelchair. September 10th, 1994 was my day that lived in infamy. I was playing linebacker in football. I went in to make one more tackle and I suffered a C5, C6 implosion of the vertebrae. I went up to grab my friend's hand and I couldn't flex my hand. I went from being able to bench press 430 pounds to zero in a single second.
When a spinal cord gets injured, effectively it's a bruise. Most spinal cord injuries actually are relatively small. At the end of the day, maybe the size of a grape. An injury, even of the size of the grape, has huge consequences in terms of communication between the brain and the spinal cord. The brain can't communicate with muscles. The spinal cord below the injury can't send impulses up to the brain.
The hardest thing is actually not being able to squeeze your wife's hand. It hurts not to be able to pick up your son and to comb your daughter's hair. It's beyond painful. My father and I, Don and Reed, we realized there's a lot of great science going on, but there's science we're scattered. There are people working here, and actually people are kind of reinventing the wheel and even doing some of the same science. And so we actually created the Roman Reed Law. And the Roman Reed Law did have a very great unifying effect for spinal cord injury. Maybe my football career died, but my patient advocacy career was born, and that to me is way more important. To find a cure for someone living with paralysis or to go score a touchdown, I'd rather find a cure any single day of the week. So people living with spinal cord injury should take heart because there's great leaders working right now.
We work at everything from a very molecular level all the way up to working with people with spinal cord injuries. In most injuries there is some sparing, and that's important. Some of the connections are still there and don't work for whatever reason. And actually, one of the reasons seems to be that they lose their insulation. So the myelin is the insulation, and that turns out to be one of the targets for stem cell therapy that actually is the first one that's coming online, at least in terms of clinical trials.
Oh, the Geron trial. This is so big. This is huge, groundbreaking. We can actually, for the first time, have FDA clearance to be able to take an embryonic stem cell and turn that into a cure.
This actually has just been approved now for of the initial clinical trial, and everyone, of course, is hugely excited about this. And the idea of the Geron therapy that was actually pioneered by Hans Kiersted's work here is to transplant cells that have been differentiated into what are called oligodendrocyte precursor cells. When implanted into the spinal cord, These cells reform the myelin sheath and restore communication. Even a relatively small improvement in function can make a huge difference in quality of life.
Autism is characterized by abnormalities in social interaction, impaired verbal and nonverbal communication, and repetitive obsessive behavior. Today, with medical advancements in stem cell treatments, we're able to treat patients with this ailment. We want you to know that the technology exists that has proven to improve this terrible disease. We've treated many patients, and 85% report significant improvements. Do you want to see real results? Here's a real patient's experience before and after. It's not just our patients experiencing success, but you've probably seen talk about stem cell procedures and their promising results on major media outlets such as the New York Times, ABC, NBC, and many others. The question is, why go anywhere else? We're responsible for training hundreds of doctors to perform these procedures, and we'll be sure to put you in the hands of the top doctors in the world, along with the most up-to-date training of any other practice. Call us today and find out how easy it is to get stem cell treatment. Have you been told that there is no effective treatment for your COPD? Do doctors have you on a strict regimen to simply not get worse? Have you tried oxygen therapy, pulmonary rehabilitation, or medicines such as methylxanthines or oral corticosteroids? Or perhaps you've even gone as far as surgery, such as lung volume reduction surgery, lung transplant, or a bulectomy. We want you to know that the technology exists that is proven not only to manage your COPD, but to possibly reverse the effects of COPD. We've treated over 400 people, and 85% report an improvement in their overall health and vitality. Think you can't get back on your feet? See what this patient had to say.
Approximately 3 years ago, I started having problems with breathing. I went to the doctor and I was diagnosed with COPD, and it unfortunately continued to get worse, and I ended up in the hospital with respiratory failure and on a ventilator for about 6 days. And then I found this. I was so excited. For some reason, I knew this was exactly what I needed. And my hope is that after this procedure is finished, that I will still be able to do a few things that I could have done maybe 2 years ago. Walk my dog around the block, go to the mall and go shopping. I would even like to be able to walk through the airport and do a little more traveling. I had the treatment, the stem cell treatment for COPD, the IV plus the nebulizer. It was the best money I've ever spent in my life. I took my niece to Las Vegas in July. I had this done in April. I took Morgan to Vegas in July for her 21st birthday, just me and Morgan. I was able to travel with her. I went to the hotel. I didn't have to have help. No wheelchair or anything. I've also found that, it wasn't an overnight deal, but every day I'll be doing something and I think, oh, why? I couldn't have done this.
It's not just our patients experiencing success, but you've probably seen talk about stem cell procedures and their promising results on major media outlets such as the New York Times, ABC, NBC, and many others. The question is, why go anywhere else? We're responsible for training hundreds of doctors to perform these procedures, and we'll be sure to put you in the hands of the top doctors in the world, along with the most up-to-date training of any other practice. Let us try to help get you back on your feet. Call us today.
A world-first medical breakthrough has been achieved by Brisbane scientists who've grown a human kidney. Researchers at the University of Queensland hope their work will save thousands of lives.
In a small Brisbane laboratory, a big discovery, a mini kidney grown from stem cells.
It doesn't quite look like an embryonic kidney at the moment, but the structures it's forming are very similar.
It's about the same size as a contact lens, but alive and functioning. It's a world first.
What you're looking at is a mini kidney, which is our kidney is required to filter urine and take toxins out of the body as well.
Kidneys are made of tiny filters. This is a model of an adult-sized one.
It's a bit like a pool filter.
Staff at the University of Queensland's Institute for Molecular Bioscience created the mini organ in a petri dish as part of an urgent battle against a deadly disease.
Kidney disease is a big killer. 15,000 people die from renal failure in Australia each year.
It's becoming increasingly urgent because the rates are climbing. As our obesity goes up.
More mini kidneys will be made here, initially to test the effects of new medication. But scientists here dream big. Their aim, to one day transplant one of these into a person.
The ultimate goal is to save lives and help people with kidney disease.
George had said 7